Let's look at the TCAP 8th grade item release questions. The first question that we're going to look at is, what is the value of x in 64? With these multiple choice, you can probably plug and chug and see what will work. Another way is you could solve this equation by doing the inverse operation. When something's being raised to the third power, you can take the cubed root, and the cubed root and the exponent of 3 cancel each other out to leave you with an x. So we have to think about, what number could I multiply 3 times to give me 64? And I would probably guess that this question would not be on the calculator section, so we would need to do this without the calculator. 4 times 4 times 4 actually gives me 64. So x would equal 4. The next question, Bob's living room is a rectangle that measures 9 by 12 feet. I could see this question being on the calculator section and the non-calculator section. If you're looking at a rectangle, the diagonal would be considered your hypotenuse in a right triangle. 9 would be one leg, 12 would be the other leg. You could use the formula hypotenuse equals the square root of a leg to the second power plus the other leg to the second power. You could plug all this in your calculator, or you could work this out by hand. 9 to the second power is 81. 12 to the second power is 144. 144 plus 81 gives you the square root of 225. 225 is a perfect square, and the square root of 225 is 15. You could also think about your Pythagorean triples. 3, 4, 5 is your Pythagorean triple. And if I multiply 3, 4, 5 by 2, I get 6, 8, 10. If I multiply 3, 4, 5 by 3, I'm going to get 9, 12, and 15. And that's what we have here. The next question, which graph represents a function? A function is where your x values do not repeat. So A is the only one that is a function. C has repeating x values, D has repeating x values, and B has repeating x values. Which statement about the equation is true? If you remember in previous videos, we talked about what is considered to be one solution, no solution, or infinitely many solutions. In this particular example, when I distribute in the 5, I get 5d plus 55. On the other side, when I distribute in the 2, I get 2d minus 38. Notice that your slopes, and I'm talking about slope-intercept form, that your slopes are different. That gives me one solution. So this is a good example of one solution. If I look at my coefficients, the numbers that are in front of D, those numbers are different. So I would say it's one solution because you have different slopes. No solution would have an example of maybe 2x plus 3 equals 2x minus 4. You've got the same slopes, the 2 and the 2, but you have different y-intercepts. Same slopes, different y-intercepts. When you graph this, you'll see two parallel lines that'll never cross. One solution, they will cross, and the intersection point will be your solution. Infinitely many solutions, you will see something like everything will be the same. Everything will be the same. Infinitely many solutions. If you graphed it, you would graph the exact line right on top of the other one. Yasmin reflects triangle ABC over DE. She's labeled the reflected triangle A prime, B prime, and C prime. Which statement is not true? When you flip, rotate, or slide, your angles and your sides are going to stay the same. So measure of angle A is going to say 76. The measure of angle C is going to stay 43. The measure of side AB is going to stay 7. The measure of AC, notice they're trying to trick you in two ways. You have to know which side you're talking about. It needs to stay 9. Well, it's saying that it's changing to a 10. Well, that's not true. When you flip this over, it's going to stay 9. The only way that this triangle would change its side measurements if it was a dilation. Daisy estimated a certain expression to have a value of 300. Which of these expressions could be one Daisy estimated? So we need to select 2. Now, the word estimation tells me that this is going to be found in the non-calculator section. So I'm seeing that all these expressions have pi. Remember that pi stands for 3.14. So we're going to do all this without a calculator. One answer choice that sticks out is 300 times pi. That looks easy to do. 300, maybe just multiply by 3 instead of 3.14. 3 times 300 gives me 900. Remember, our goal is to look for 300. That's not it. And then what about 100 times pi? 100 times 3. Well, that's close to 300, so I would definitely pick that one as an answer choice. And just kind of working my way, you notice that we've got orders of operation that we need to pay close attention to. Here, I need to do 5 times 3 first. 5 times 3 gives me 15. Then I'm going to take 15 to the second power. So that'll be 15 times 15, which we did just a minute ago, taking the square root of 225. So 15 times 15 gives me 225. Not really close to 300. Here, I've got 10 times 3, and I'm just using 3 for pi. And then that gives me 30, but then I have to do 30 squared. 30 times 30 gives me 900. That's too large. Let's go back up here, where first my order of operations, PEMDAS, please excuse my dear Aunt Sally, I need to do 3 to the second power, which gives me 9, and do 9 times 10, which gives me 90. That's not close. Here, pi to the second power is 3 to the second power, which is 9, and then I'll do 9 times 30, and that gives me 270. So that's pretty close. The contractor is determining the amount of materials needed for the construction. He knows he will use 32 nails for every sheet of plywood. Which graph represents the relationship between the number of sheets? So for one sheet of plywood, notice where they're putting the sheets of plywood. They're labeling it down here at X. Also, you can think about this being proportional. This should go through the origin, because if I'm using 0 sheets of plywood, I'm going to be using 0 nails. So we can already eliminate A and B. Those don't seem to be going through the origin. Now, I'm going to use 32 over 1 as my rate. And if I look at C, that's probably hitting somewhere around 32. Remember that for a proportional relationship, you need to have Y over X. So Y is representing my number of nails, and 1 represents the sheet of plywood. Here they seem to have it backwards. They have the sheets down here, but this number right here is saying that I'm using 1 nail for about maybe 28 sheets of plywood, and that's not what the problem is indicating. The water levels in a holding tank of water, the treatment plant, are continuously monitored and graphed. Over a 5-hour period, the water level had these properties. The tank is starting full, so if you look at all these graphs, they're all starting at 100%. Remember, we read a graph left to right. The next one is the water level decreased at a constant rate. So this one's showing that it's decreasing, this one's showing that it's decreasing, this one, and this one. The next one, it says the water level decreased at a slower rate. So that should be the second section. Here, we're showing that it's increasing, so it's not A. Here, this one's showing that it's decreasing at a slower rate. Here, it's decreasing at the same rate, so it's not C. And here, this looks like it's decreasing at a faster rate. So the answer choice is B. We can keep going and line up each of the other sections. The other section indicates right here that we are going to remain constant at a rate. So these sections match up better than all the other answer choices. The graph shows a scatter plot. Which equation best represents the data in the scatter plot? Here we're going to draw a line of best fit. And if you notice, all of these are in slope-intercept form. The easiest thing to figure out would be your y-intercept. If you notice, the line that I drew is somewhere between 1 and 2, maybe close to 2. And I'm noticing that this equation has an intercept of 2. And it's the only equation that has an intercept of 2. I could also analyze the slope. The slope in this one is almost 1. I could think about going up 1, right 1, up 1, right 1, up 1, right 1. Roger has 2 stacks of colored cards. These cards are the same shape and size. The table shows the number of each colored card he has in each stack. Remember, probability is what you want over the total amount of cards. There are 20 cards in stack 1, and there are 20 cards in stack 2. Roger will randomly select one card from each stack once. Which statements are true? We need to select 2. So for A, the probability that Roger will select a red card from stack 1, there are 8 red cards out of 20. That fraction reduces down, if we divide by 4, to 2/5. And then a blue card from stack 2. Blue card would be 5 out of 20. And if we reduce that fraction, that gives us 1/4. When we have 2 different events, we need to multiply these together. 2/5 times 1/4, which multiplies straight across, gives you 2/20. Reduce your fraction, that gives you 1/10. Now we're supposed to get 1/3. That didn't happen, so I'm not going to choose A. Answer choice B, the probability that Roger will select a purple card from stack 1. There's 2 purple cards out of 20. That reduces down to 1/10. A purple card from stack 2 would be 6 out of 20, and that reduces down to 3/10. Multiply these 2 together. Just multiply straight across. That gives you 3/100. Not 3/5, so that doesn't work. C, we're selecting a yellow card from stack 1, which is going to be 6 out of 20. 6 out of 20, remember, reduces down to 3/10. A red or blue card, red or blue, so we need to add up the red and blue, so that gives me 8 out of 20. 8 out of 20, remember, reduces down to 2/5. Multiply these together, 3/10 times 2/5, multiply straight across, 6/50, reduce the fraction, 3/25. Ooh, 3/25, 3/25. All right, we got 1. D, the probability that Roger will select a card from stack 1 that is not blue. Okay, so we have 4 blue cards. I want everything but the blue cards. So that's 16 out of 20. That reduces down to, let's see, divide by 4, 4/5. Then from stack 2, we want something that's not purple. Okay, so we have 6 purples. So that would be 12 out of 20. No, 14 out of 20. Reduce that. That gives you 7 over 10. So we need to multiply 4/5 and 7 over 10, which gives you 28 over 50. And we could reduce that, but we're seeing that it's not 1. We should get 14 over 15 is the probability. Here they're saying it's 1, so it's not D. Hopefully it's E. Let's see. The probability, and I think what I'm going to do is I'm going to come up here and work it out. The probability that Roger will select a yellow card from stack 1. So that would be 6 out of 20, which reduces down to 3/10. And then a card from stack 2 that's not red. So red we have 3, so that would be 17 out of 20. And I'm just going to bring that up here because I can't reduce that. Multiply straight across. 3 times 17 gives us 51. 10 times 20 gives you 200. And here they're saying, is this greater than 25%? Remember that a percentage is out of 100. So if I divide the top and the bottom by 2, I get a denominator of 100. Half of 51 gives me about 25.5%. So that is greater, just barely, than 25%. So yes, E and C are our answer choices. What is the value of y in the solution of the system? We need the value of y. If you notice, these two are in standard form, ax plus by equals c. And if they're both in standard form, the best way to solve this system is using elimination. If I added up my x's, I would get 5x. If I added up my y's, that would give me 3y. So nothing seems to be eliminating just yet. But I hope that you notice this y right here. If that y was a negative 2y, then your y's would cancel out. So let's make that bottom equation have a negative 2y. Let's multiply the entire bottom equation by negative 2. The first equation we're not going to change. I'm just going to bring it over. Negative 2 times 2x gives you negative 4x. Negative 2 times y gives you negative 2y. And negative 2 times 4 gives you negative 8. Now we're going to add up the x's. That gives you a negative 1x. When we add up the y's, they're opposites and they eliminate. That's the name of the game. When you add up negative 12 and negative 8, that gives you negative 20. Continue to solve this equation by dividing by your coefficient, negative 1, and x gives you positive 20. Now, you see 20 over here, but don't circle it. Go back and read the directions. We need the value of y. Plug that 20 into either one of these equations. And honestly, I would pick this one. It just has less numbers. So you've got 2x plus y equals 4. We know what x is. So 2 times 20 plus y equals 4. So we're going to solve this equation for y. 2 times 20 gives me 40. Subtract 40 from both sides. And y gives you the negative 36. And that's A. What fraction is equivalent to the decimal number 0.90 repeating? What I would recommend is knowing that you're not going to be able to use a calculator on this. This is a type of question that will be in the non-calculator section. So what we're going to do is we're going to build an equation. I'm going to give you the answer. We're going to say that x is 0.90 repeating. But our answers are going to be this in a different format. Same value, just a different format. We're changing this repeating decimal into a fraction. Then I want you to understand how many decimal places are repeating and really understand what's going on here. 0.90909090 and so forth. We are repeating our 100th place value. So that tells me I'm going to multiply both sides by 100. If I was only repeating in the 10th place value, I would multiply both sides by 10. Remember the shortcut that when I multiply decimal by 100, all I'm doing is moving that decimal to the right 2 places. So now that's going to give me 90.90 repeating. So all I did was multiply both sides by 100. Then I'm going to subtract x from both sides. Now remember, x represents this repeating 0.90. So I'm still subtracting the same amount from both sides. It just looks different. 100 x's, take away x, gives me 99 x's. Now you can see that I have 90.90 repeating minus your repeating. So all that's really canceling out is your repeating portion. So that leaves me with 90. And then you just divide by the coefficient and reduce your fraction. 9 will go into 90 and 99 to give you 10 over 11. A linear function is represented by the table below. Which 2 statements are true? When you have a table, really easy to find your slope. 8 to 11, we're adding 3. And we can continue this pattern or just skip over to the x side. 2 to 3, you're adding 1. So your slope is y over x, which will be 3 over 1, which is 3. So it can't be that one. It could be this one. It could be this one. Or it could be this one. So we got to figure out the 2. The next thing that we could do is kind of work backwards and figure out the y-intercept. So for our y-intercept, my x has to be 0. So if you notice, from 0 to 2, I'm adding 2. Well, what is going to be my number here to give me a slope of 3? 6 divided by 2 gives me 3. And then 8 minus 6 gives me 2. So that would be my y-intercept, which is right there. So if I have a y-intercept of 2, I can't have a y-intercept of 0. That's not going to work. The area of Texas is about 2.69 times 10 to the 5th square miles. The area of Delaware is about 2.5 times 3 square miles. How many times larger is the area of Texas than the area of Delaware? So we're going to divide these scientific notation problems. Now you can easily put this in your calculator, but I have a strange feeling that this question would be on the non-calculator section. So we're going to do it without a calculator. Remember that when you have the same base and they're stacked, you can subtract those exponents. So 5 take away 3 is going to give me 2. Then we're going to divide our coefficients. So we're going to do this by hand. 2.5 into 2.69. Remember that we got to move that decimal over. 25 goes into 26 one time. 25 will not go into 19. We'll bring down a 0. 25 will go into 190 7 times to give us 175. Make that a 10, make that an 8. That gives us 15. add another 0, bring it down. 25 will go into 150 6 times. So we got about 1.076 times 10 to the second power. But all your answer choices are not in scientific notation. So what we're going to do is we're going to move that decimal over 2 places to give us about 107.6, which is about 108. What is the distance between 8,3 and 5331? Typically, I would say graph this on a coordinate plane and find the hypotenuse. But with that number being so large, I wanted to show you a different approach. This is your first x, this is your first y, this is your second x, this is your your second y. The distance formula is based off your Pythagorean theorem, which is the square root of your second x minus your first x. So you're just taking the difference of your x's, raising it to the second power, plus the second y minus your first y to the second power. Very similar to the hypotenuse is the square root of the leg to the second power plus the leg to the second power. So to get those leg measurements, we have to take the difference of your x's. So 53 minus 8 raised to the second power. And then the other leg would be the difference of your y's. So 31 minus 3 to the second power. So 53 take away 8 gives us 45 to the second power. So one leg will be 45. 31 take away 3 gives us 28. So 28 would be the second leg. Plug all this in your calculator, you get 53.